Hi, we are Team 47, and my teammates are Nikhil, Dipanshu, Kaushik, and I'm Ayush. We have worked on the idea of a marketplace based healthcare solution. Now, who likes to wait outside doctor's clinic for hours doing nothing, missing schools and home offices sometimes? Nobody, right? This is where our idea steps in. We have tried to make the entire process of doctor and patient interaction as easy and accessible as possible. We respect your time, and so should you. Now, we have tried to make a one place online platform for doctors and patients to chat online, among other facilities which will be discussed later. Now, these are some of the technologies that have been used in implementing this project, WebRTC being the most important one. Now, I've tried to give a brief outline of how our system works. As I've told you, we have tried to make this as simple as possible. Once a patient logs in, he is redirected to a page that shows a list of online doctors. The patient initiates a video call, and on the other side, the doctor is notified of a patient waiting for him to connect to. And this is how they get connected and start talking. Some of the other functionalities that have been included are separate login for both patients and doctors, the ability for patients to search doctors on the basis of specialization and location, for a patient to view a doctor's profile or his own profile, and the video conferencing and messaging facility that have been discussed already. Now let us see how our project have evolved over time. Since this was the first time we worked on a software project of this scale, we had to get ourselves familiar with version control and techniques involved in software development like development models, testing methods, Git, etc. Documents like SRS, project plan, and project concept were carefully prepared that guided our development till the end. WebRTC was the base of our project that was used in the development of the video conferencing module. WebRTC is a free, open source project that provides browsers and mobile applications with real-time communication capabilities via simple APIs. This is a brief outline of how our WebRTC connection is made. Now let's discuss about how some of the functionalities were implemented. Login was implemented using Passport.js, which is an authentication middleware for Node.js. We also employed JWT for encrypting the passwords. The entire module of the video conferencing part was prepared using the WebRTC library. We used the Turn and Stern network protocol on the server side for better connection handling. We prepared a dashboard to show a list of doctors and patients that are online, and a notification facility for doctors to be notified when the patient is waiting. Notifications were made using Socket.io modules, using WebSockets for better two-way handling. The search feature includes the functionality of autocomplete, and we have a separate login for both doctors and patients. Messaging was implemented using Socket.io module, and for better scalability of handling messages, Redis PubSub is used as a messaging queue. We integrated all our modules using a bottom-up approach and tested using Mocha and Chai, which is a testing software for Node.js. Our project is hosted on Amazon Web Services. HTTP over TLS is implemented in the application to handle the secure encrypted request. Now, as you have may noticed, our project requires a lot of technologies to be learned. We followed Scrum, adding user stories evolutionary. We also followed design patterns and tried to make our backend as flexible and scalable as possible. The aim of the project was to develop an MVP for the startup idea of a client, and hence we focused more on adding functionalities rather than the UI component. Now, here's a live demo of our project.
Now I'm logging in a user named Nikhil, and we could see that he's a patient here as he has message doctor, and even now I'm logging in a user named Ayush. He's a doctor, and he could see the other patients in his list in the dashboard. So now let's go with the messaging part uh, we implemented in our release 2. So suppose Nikhil wants to chat with Ayush, and he clicks on message doctor. So doctor gets a notification that the patient is waiting for him, and he could directly go and click on message patient with Nikhil. Now, so Nikhil types something like, "Hello, doctor. I feel some pain in my stomach." And doctor receives it. You could see here it is Ayush and here it is Nikhil. So let's see it parallelly how this is actually working. So I kept doctor to the Nikhil to the left and doctor to the right. So okay, so now doctor sends another message. Can you please elaborate? And Nikhil receives the message. And now again Nikhil sends. Uh, I feel this every morning. And then doctors gives the suggestion. This continues till this problem is solved, and doctor could call him to his uh, hospital, and many more. For implementing this messaging part, we have like use Socket.io and then also use Redis to make this messaging scalable. We used Redis PubServe as a messaging queue and made this more scalable. So now returning back to the dashboard. So as we know, we have shown the video conference module before. Suppose if Ayush wants to chat with uh, Ayush wants to chat with Nikhil, then he clicks on meet patient, and now Nikhil gets a notification that Ayush is waiting in his room, and when he clicks on chat, and then he will be redirected to the same room where everything is parallel. And also, we have implemented the search functionality where a user can search for other users. So uh, if a patient wants to search for a doctor named Ayush, he clicks Ayush and he gets a link over here. So if he clicks on this, he'll be redirected to the profile of a doctor. So, and even this, on clicking this, he can see his own profile. And these are the recent messages the user has got. So you can see here that Ayush and Nikhil has chatted last at 4:19 p.m.